is Chaz Emerick, and I am the co-author of Clojure Programming from O'Reilly. And what I'd like to do today is bring you through really the very first steps that anyone would take, or that many people might take, in getting started with Clojure, and from a very practical standpoint. So just to run through a couple things about me and why you might want to listen and watch. I've been developing software for a very long time. Started using Clojure in 2008 and have provided contributions to both the core language and various libraries around it. And as I said, I am the co-author of Clojure Programming from O'Reilly, along with Brian Carper and Christoph Grand, two other excellent programmers within the Clojure community. So if you're in this room, you probably know what Clojure is on a basic level anyway, and I'm not going to spend too much time on this. Just to give a brief overview for anybody who isn't particularly familiar with it yet. It's a dynamic general-purpose programming language, and it runs on the JVM as well as .NET, and it can be compiled down to JavaScript and other languages as well in different incarnations of the language. But we're focusing on the JVM in this webcast. And it has a couple of key points of emphasis. One is functional programming, and functional programming is in contrast to, for example, imperative programming, where you would be describing how your program should operate from step to step to step. Functional programming carries along with it a number of different characteristics that enable simpler solutions to certain problems and a lot more clarity and power in addressing more complicated domain-specific issues. And along with the functional programming aspect, Clojure does emphasize things like immutable data structures and carries along with it a very sophisticated approach to concurrency and parallelism. Those are more advanced topics, which I'm not going to get to that much here, but they are key marquee features of the language. In addition, Clojure interoperates very well with both the JVM and all of the Java libraries out there in the ecosystem. That means that doing practical things in virtually an environment is very doable with Clojure, where you might otherwise need to use something like Java if you have legacy libraries or need to interoperate with other teams or organizations that use JVM technologies. Then Clojure is a great fit for that. And one thing that's really key about Clojure, and one thing that I like to emphasize, is that it enables very interactive development. This means that, and this is a concept that we I think coined the term of REPL-oriented programming. I don't know how accurate or helpful that is for people in terms of understanding the notion of it. But if you are familiar with, for example, Python, the Python interpreter, or IRB in Ruby, and the very elastic direct control that you have over the program that you're building, usually small scripts in those environments, that is pervasive throughout Clojure, especially if you're using good tools to develop in it. So we'll see what that means and what that implies for the workflow, but it's a key point in what Clojure can provide to you. So what we're going to do here, I'm not going to talk anymore about Clojure in the abstract. The bulk of this is going to be me sort of flying by the seat of my pants, building a Clojure web app from scratch. First, we're going to set up, or I'll walk through the steps that are required to set up a productive Clojure development environment. For myself, that means using Eclipse with the Clojure plugin called Counterclockwise. This is specific to Eclipse, but there are Clojure development environments that are equivalently capable for Emacs, Vim, NetBeans. I haven't used the one for IntelliJ, but I hear good things. So nothing here is going to be Eclipse specific, except for maybe 2 minutes just showing how easy it is to get those plugins installed so that you can use it. And in addition, the project and the project management and build tool for Clojure called Leiningen. This is the Clojure corollary to, say, Maven or Ant, but it's significantly simpler and provides a lot more power and extensibility in important ways. I'm not going to get into Leiningen much at all here, but it's a key part of being able to use Clojure productively, and it integrates well into the Eclipse and counterclockwise environments. And as I said, the objective here is to build a Clojure web app from scratch and going to be doing it interactively, again, going back to that notion of REPL-oriented programming that I was talking about. So I think without further ado, I'm going to turn on some screen sharing here, and hopefully this works. If people can't see my screen, you should be seeing an Eclipse environment here with a terminal in front of it now. Hopefully that's coming through. Now let's see. So I'm definitely going by the seat of my pants here, but so we're going to start off creating a new project. This is going to be using Leiningen. You can go to leiningen.org, and I guess people are still seeing slides.
We can see your screen share, Chaz. I'll give some support to folks in the chat room who can't see it.
Okay. So you can go to leiningen.org to get a sense of what Leiningen is like, but I already have that installed. I'm not going to go through the installation process for that, and I'm going to be using version 2 of Leiningen, which is in preview right now. So we're just going to do line new. What this is doing is going to be creating a new project. This is using the default template that is built into Leiningen for creating a new project. So if we go into test web, it's put together a small template for us, and we can see what's in the project.clj. This is the corollary to the build.xml or pom.xml. And as you can see, there's not much there. There's just a description, some coordinates. You may recognize the 1.0-snapshot. That's a typical Maven version number. So Leiningen reuses the entire Maven dependency system for tracking dependencies and publishing and deploying and consuming transit dependencies and all that. So that simplifies things, especially if you're coming from that environment. And if you're coming from Ruby or Python, this is equivalent to easy install, although that may be from that may be dating me a bit in my Python knowledge. scons or rake and bundler in the Ruby world, that kind of thing. So we have a Clojure project here, and it just stubs out a bunch of a couple source files, one for the main source and one for the testing. So there are a number of templates when I ran line new test web that use the default. There are a number of project templates that are available and published for doing web development, for working with different types of databases, and on and on and on. There's a feature in Maven that provides this same type archetypes. That Maven archetypes would be the corollary to that. Although again, the Leiningen implementation is quite a bit simpler, in my opinion, than the Maven one. So we now have a project. Without getting into Eclipse just yet, let's just see what some Clojure looks like. So all that is a namespace declaration for the testweb.core namespace. That's just the default one that line new stubbed out. So you'll notice that we have a source directory here, and then another subdirectory called test web. It could be anything. And then we have a core.clj file. There's a correspondence between the directory structure and namespaces within Clojure that is similar to the correspondence between packages and classes and the directory and file structure in Java. So you see that the namespace testweb.core corresponds to the directory structure and file name that the source file is found within, with the exception of the .clj extension. So I'm going to get into Eclipse now. We're going to open this project up and start building something. First, I want to show you how easy it is to get counterclockwise and the Leiningen support installed. I don't think you'll be able to see my menu bar here, but I'm selecting from the Help menu the Eclipse Marketplace. And this is a single source location for plugins for Eclipse. So if you just search for Clojure from within the Eclipse Marketplace, then you'll get to the counterclockwise installation process. And then it's just like any other plugin for Eclipse. And it's going to say there's nothing to update because I already have counterclockwise installed. Basically, you just accept all the dialogues running through this process, and you will get to the final installation screen that will provide you with counterclockwise. That includes all of the Clojure-specific support elements for running REPLs and code completion and all that. The Leiningen installation is that's not in the Eclipse Marketplace. What you would need to do is bring this URL into the list of install sites that Eclipse can use for installing new software. And I think maybe we will include this in some show notes later or something. But if you go to, I don't have a URL handy for that. Anyway, you just plug in the URL to Eclipse. Again, just like any other Eclipse plugin, check off the appropriate box here. Next, next, next. Okay, everything. Chances are we'll want to restart. You'll do that, and then you'll have Leiningen support. So let's dig in and open this project. We are going to create a new project and use the location that I had specified here. Test web. Oh, I see. So now we have our test web project here. If you can, do ignore the rest of my workplace, as messy as it is. And then there's two other things that you currently need to do to have this recognized and usable as a Clojure and Leiningen project. First, configure it as a Leiningen project under the, what I'm doing is right-clicking on the project, choosing Configure, and then choosing Convert to Leiningen project. What that's going to do is it's going to pick up the project.clj file that we already saw. It's going to recognize the dependencies found within that, and then populate the class path and manage that entirely. So you don't need to deal with the Java class path. You don't need to worry about that, especially if you're coming from Python or Ruby and you're not familiar with how the JVM class path works at first. Using Leiningen top to bottom simplifies all that work for you, and the plugin here for Eclipse does the same. And now we're going to enable the Clojure language support that will provide us with code completion and good highlighting and that kind of thing. And so now TestWeb is a fully featured Clojure Leiningen project that we can use as we would like. So I'm just going to start a new Clojure app. This starts up a REPL by default, and counterclockwise is going to start a REPL at the bottom here. And we can, evaluate expressions and such. So that concludes the Eclipse setup essentially, and so now we're ready to do some actual Clojure. And as I said, I'm running totally by the seat of my pants here, although I do remember the dependencies that I need to add. So I'm adding two dependencies here, Ring and Clojure. Ring is the foundational web framework for Clojure. Corresponds very, very roughly to what you would expect in Rack, for example, if you're coming from Ruby, WSGI if you are coming from Python, and I'm not sure what the corollary with Java would be, but that's roughly what you work with instead of, say, bare servlets. You can deploy Ring applications on top of servlets, or as a servlet, I should say, but that's the closest corollary. And then Clojure provides a number of, and people are providing helpful links in the chat. Thank you very much. Clojure provides a number of helpers that sit on top of Ring, including routing, a bunch of middleware to support things like handling parameters and file uploads, that kind of thing. So I'm actually going to kill this REPL, and we are going to dig into some actual code. So I'm just going to make sure that our new libraries are in place. And so if I'm not mistaken, we won't need to restart the process at all from here on out. This is part of my part of the emphasis I'd like to place on the interactive development portion. So we now have everything available that's on the class path. Again, you can see the dependencies that were pulled in associated with Ring and Clojure. And we'll build the web application from scratch using just what's on the class path right now, and we won't need to restart. So in a lot of environments, if you change something, sometimes you have a daemon process in the background that will refresh what is on the class path if you're using a Java app, or in Python, just restart the whole process entirely. The downside of those sorts of approaches that you lose your state. You lose the data that's resident within your application each time that happens. In Clojure, that's not the case. You retain all the state that is within your process, and you can manipulate the functions and data that are defined within your application as you need to as you're developing things. So I'm going to bring in a couple of core namespaces here. So we're going to keep this testweb.core namespace. That's what we're going to be using for the top level for our web application. And what I'm going to do is rebuild from scratch the example from, I think, chapter 16 in Clojure programming, which is a URL shortener. Whatever your opinion of URL shorteners, they are a useful example for building web applications because it does involve a little bit of persistence, non-trivial routing, that kind of thing, and we'll see how much we can get done within the hour, or let's say within a half an hour to allow for QA and such, and hopefully we'll have something useful at the end of the day. So I'm going to use some parts of Clojure here. Just post, and now we have a running REPL, and I can send code to it at any time. So for example, there's this symbol def routes here. I'm going to switch that namespace. As you can see, it's not defined yet. But if I reload it, then, oops, now it's defined. That's one of the benefits of having the REPL available and open all the time, is that you can bring in new pieces of code, you can bring in new libraries depending on your environment and use those dynamically. So I'm going to bring in another piece here. And we'll see what each of these is used for as we go along. I just want to get some basic imports essentially put together before we really start working. And I just happen to prefer not to have counterclockwise build in the background. It will run. Oh, look at that. Well, this is what happens when you do things live. So we're missing a library. Oh, no, we're not. I misspelled the library then, or the namespaces. So let's get on with it here. So now let's talk about Ring for a second. So Ring, as I said, is the fundamental abstraction for web programming, essentially within Clojure. What it does is provide an abstraction for both request and response, whereas in Java you have, for example, a HTTP servlet request that you read data out of, and there's a mutable body that you pull stuff out of, and then a response that you can write stuff to willy-nilly. Really not a whole lot more abstracted from the original CGI, where you're just writing to standard out. In this case, in the case of servlets, you're writing to a output stream provided by a servlet response object. In Ring, both request and response are represented as data, just regular Clojure maps. And handlers, as opposed to Java, again, where you need to implement a particular interface or a particular subclass, depending on what framework you're using. Ring handlers are just functions. So I'm just going to define a simple function here that will take the request map and then return the URI, so it would be the path segment as a response. So we'll do that, load it. We see that we now have this new app var here, and we can call that function with any data that we want. And actually, this is one of the strengths of Clojure using immutable data structures. We can very, very trivially mock up what we would expect as requests to our app function here by providing something like that. So we see that it does return the URI in the request map, and that's going to be returned. If you return just a simple string, then Ring turns that into a full response, going back to the browser. And so we can start up. Let's create a little function here that will start a server for us, since we're going to do this a couple of times. I'm just going to we need to bring in the adapter for Jetty, so Ring can run on top of virtually any Java servlet container, including Tomcat and WebSphere and WebLogic and et cetera, et cetera. A lot of Clojure development actually uses Jetty, which is an embedded container and web app server. So Jetty. I just wrote this function called run, takes no arguments, and it's going to call this function run jetty, provide it with a reference to the var holding our app function that's going to act as the top level handler for our ring application, and then a little bit of configuration. We're going to run on port 8080, and this join parameter means that it is not going to block on the return or the closing of that server. So we're going to load this, and if we run this, we should now have a running server, which we do. And I'm going to bring a browser into view here, and oops. So we didn't get anything because the path is empty, and so now if we access a URL, something's gone wrong. So as you can see, what I'm doing here is I'm on the request. I am defining a new var. Generally, you don't do this within Clojure applications, defining new vars within functions, but I'm doing this here because something's gone odd and I'm not quite sure what. And you can see here is what a ring request looks like. It has all the components of a web request that you would expect, and certainly has the URI of foo sitting there. Yeah, no, a couple of comments saying that you need to write the response, but no, that's not generally required. Oh, yes, that's true. So I haven't brought in the Composure stuff, which provides that helper functionality. So I do need to provide a proper ring response map. I almost always actually use Composure instead of, there we go. I almost always use Composure on top of ring, which provides the ability to return a simple string. Thank you very much, Fred. I appreciate that. I almost always use Composure on top of ring, which provides that functionality of being able to return a simple string and have it turn into a web response, but I didn't do that in this case. So let's, what we're going to do is rename this app star. I'm going to return the URI again here, and then define the actual app as, let's see, Composure handler. Oh, site. So it's called site, not app. So now what I've done is I've applied this site function is middleware that wraps my app function, and now I can use the hash tick here to get the var of that instead of the top level. And now the Composure site middleware does all of those things. It allows you to return a simple string, as I will continue to do here. It handles form parameters. It handles uploads, that kind of thing. So we'll reload and go back to our browser, and now we're back to where we were. Oh, I know what I should have done. So I'm going to restart the Jetty server on another port because I didn't return a reference to the server, so it wasn't picking up the updates. So now we're going to go to 8081. Back in trouble. Well, this is live TV, folks. Well, I guess I'm just going to use the helper for right now. And now we're back to where we were. So let's start building our application. As you can see, we can, and actually I'm going to just to show you what you can do in terms of interactive development. So instead of returning the URI of the request, I'm actually going to convert the entire request to a string and then provide that back to the browser. So that's the sort of turnaround that you can get in terms of interactive development. And this is incredibly helpful in terms of maximizing your productivity within Clojure's, being able to load code dynamically whenever you like. So now let's get to work building our URL shortener here. What we need to do is we need to be able to retain the mappings between the shortened URI, the shortened URI and the full path that we specify. So we're going to set up a mapping of exactly that, the URIs to the fully expanded URLs. And then we need to be able to have some way of generating the unique IDs that will form the shortened the shortened IDs, the shortened URIs. Sorry. So I'm just going to use a counter for that, and we'll need a couple of functions to actually perform the shortening here. So given any URL string, we want to get a new ID from this counter. So counter is defined to be an atom. This is just like an atomic reference that you might be used to within Java, but it has some slightly more pleasant Clojure semantics on top of it, which I'm not going to go into in detail, but in short, you can atomically swap in a new value based on using a compare and swap operation, or you can provide a function to manipulate the value held by the atom and atomically swap out swap in a new value based on invoking that provided function with the current value of the atom. So we're going to swap into the counter atom inc, which just increments the value. So all this is going to do is going to increment the value held by the atom from 0 to 1, for example, and it's going to return us the new value, if I remember right. And we don't just want numeric IDs, so I often use the toString on long, to which you can provide a base, and a base of 36 makes for reasonably pleasant IDs, especially once you get up to larger values. So, that sort of looks like a reasonable ID, especially if you want to have a URL shortener that works up to, millions or hundreds of thousands of URLs shortened at a time. So now, right here, we have our local of ID, and what we're going to do is drop into the map the mapping between that ID and our URL. So this mapping up here, it's not an atom, it's a ref. Refs are the building block of Clojure's software transactional memory. That's a long way of saying that refs implement in memory the A, the C, and the I of ACID, for example. So you can build, essentially, a in-memory database using Clojure data structures, but it is only in memory, so there's no durability component to it. But what it does provide is all those other characteristics: atomicity, integrity, and no, that's not right. And consistency. So we are going to URL. So what we're doing here is, again, just as we used swap to change the current value of our counter atom, alter takes, we provide the reference to our ref, the name of our ref mappings. We provide a function that will change the value held by the ref after our transaction is complete. So this doSync block essentially establishes the scope of our transaction. So you can have 1,000 different clients contact your web app, try to shorten URLs all at the same time, and only one transaction at a time will succeed, so as to ensure that the mapping's consistency remains intact. So we do that alter. That means that we'll change that mapping to contain the new mapping between the ID and the URL, and we return the ID that we generated so that we can provide that to our client. So I'm going to load. It's not mappings, it's mapping. So I'm just FYI, to load the file, I'm hitting Control-L within counterclockwise. If you just right-click on any editor, you can see what all the shortcuts are. I have some custom mapping set up, but the defaults are very good, and there's a number of commands there that are good to know if you're using the counterclockwise plugin. So load that code, and let's just test it out. So we have our mapping, which is empty right now. Let's shorten that. So we want to get a short ID for Clojure.org, and we get 1. Let's take a look at what our mapping is. And we have a mapping between 1 and Clojure.org. Totally makes sense. So let's put in another URL, and we get back another ID. And again, the map is updated as you would expect. So here is what we're going to be using for persistence. Obviously, you could change this shorten function to use any database. And there's great database support for Clojure for CouchDB and Oracle and Postgres and Riak and whatever database is best for you and your environment organization. You can certainly use it from within Clojure. We're just going to continue to use the in-memory STM just because rolling database access into this as well would be would lengthen things more than necessary, certainly. So now we'll put together our web front end for essentially our database shortening service here. I like to call this retain. So this is a ring handler. So we're getting in a map that contains, let's see, whoops. So what this is a function that's taking a single argument, this map, and it's destructuring it. And destructuring is sort of like tuple unpacking, for example, in Python and Ruby, but it can be used for maps as well. What we're doing is we're pulling out the params slot from the request, and from within that getting the keyword URL. So if you provide a URL to this handler as a parameter, then we're going to return the newly shortened ID for it. So and now we're going to have a couple different handlers. One for we'll want one handler to be able to accept new URLs to shorten, and then one route to and then one route that will redirect when provided a shortened ID. So I'm going to change app.star here to use def routes, and this is going to be a set of routes using Composure routing. So we'll do, let's see here. Oops. I'm just going to stub out the other handler to redirect. So as you can see, when we get a request in that contains just an ID, so as you are familiar with any URL shortener, slash and whatever, it would be more like one of, slash 2z60w, then we'll be calling this ring handler, which will look up that ID and then redirect the browser to the requested URL. So there's a utility function within ring to do a redirect to a URL. So we will look that up in our mappings based on the ID. Oh, what did I do? So we can test that part of it as well. So we'll come down here and remember that mapping contains our, I just blew away my mapping. that makes it important to use, especially when you're doing interactive development, def once. What that's going to do is ensure that the mapping and counter bars are not reset when I reload the file. And so I'm just going to throw in a couple of URIs again, and so now we have our mappings back. And if I redirect to an ID of 1, we get back an example of a ring response map. What this is the HTTP response, which is 302 for a redirect, an empty body, and a map of the HTTP headers that will be sent back to the client, which in this case, because it's a redirect, it will be the location header. So there's that part of the app, and then we'll add a post route, and we'll post to the root URI of our app, and so here I am simply, we're accepting post requests on the root, on the root URI, and here's the ring request map. We're going to pass that to our retain function, which will set up that mapping between the posted URI and posted URL, sorry, and the generated ID. Oh, actually, I'm gonna leave this as a get for right now because we don't have a form. And actually, looking at the clock, between some of my fumblings and the technical issue, I think we're gonna run out of time to bring in in live to put together an actual page so that we can just drop in, we can just paste in a URL and get that back graphically. So I'm going to just leave that as a get route. So we should be able to now go to our app here and provide a new URL. Let's make something that's totally out of the blue. And now we come to the fun debugging part of things. That would clearly not work. And there's lots of great debugging utilities within Clojure, but I'm just going to use a simple print line here to keep things super simple. And we have an error. Unrecognized body. Right, didn't need that. So when you use the response function, you don't need to provide a body. So now we have our ID for apple.com and 5 right here if you didn't notice it. So if I go to /5 as the URI, we should get routed through our redirect and be redirected to Apple, which we're not. Let's see here. How are our mappings doing? Oop. remote mapping. So we've turned up a bug. We have multiple short links for Apple. That's either actually a bug or a feature, like a Bitly, for example. It doesn't automatically collate all of the identical URLs into one short link, so that may be a feature or a bug depending on how you look at it. But let's see what I'm doing wrong here. Oh, here we go. So Composure routes, when you specify that you're expecting a URI component here, you want to break that out into a vector. So let's, and now we just got redirected to Apple. So again, just to go back here, we shortened a URL. Let's do another one just to go through the full life cycle of things. Let's go to clojurebooks.com, which is the sort of the official, unofficial site for the book that is maintained by myself and Christoph and Brian. And I just sent that and got back the ID of 6. Again, presumably you would have more reasonable IDs than just numbers, again, going back to how our shorten function works. Once the number in the counter goes up a certain amount, you'll start getting quote-unquote proper alphanumeric shortened URLs. So now we have a short link of, whatever our domain name is for our URL shortener /6, and that should bring us to clojurebooks.com, and it does. So that is our URL shortener, and just to show you the mapping in the background, again, there's the entry for clojurebooks.com. So that's, I think now that we're up at 1:57, I've already gone long by 10 minutes. I was hoping to put together some a reasonable form so you can drop in a URL, but again, between my foibles and of that technical issue, I think we're going to probably hold it here. Hopefully this has given you a little bit of a flavor of what it's like to work in Clojure. And in particular, I hope it's given you a sense of what this interactive development is like. So you notice I didn't restart the JVM or the Clojure runtime. There's nothing in the background that's restarting. There's no tricks up my sleeve. Just loading code into the REPL, and it just works in terms of loading code dynamically and being able to interactively develop whatever it is you're working on. And a note about REPLs in general, so this is actually running a REPL server. If you'll notice the top of the tab here, it's running on localhost 49677. You can put REPLs as a part of your deployment, say in a user acceptance testing environment where you may want to tweak the code that's running on a server somewhere more rapidly than you would be able to using typical deployment techniques like deploying WAR files or even Heroku and things like that. Being able to just log in, you just choose window, connect to REPL, and you can type in any host and port name. So I'm just going to create another connection to 49677. So that's another connection into the same JVM and Clojure environment that was set up before, and I'm going to interactively go into the same namespace, and we can look at our mapping. So this could be a remote server running somewhere, running our URL shortener, and if something's going crazy, you don't understand, you're getting odd problem reports from users, you can log into your system. Even if it's in production, you're not going to push any code out to it because you want to maintain repeatability of builds and not have interactive processes touching code running in production, which is a very sane thing to want to do. Even then, you can log in and just from a monitoring and debugging standpoint, look at the data structures that are in your application through a REPL and get a sense of what that is. It's sort of like JMX on steroids is what one person recently described it as. So I think I'm going to stop it here and do Q&A for however long we want to do Q&A. I apologize for the slight mishaps, but again, that's live TV, and yeah, I hope you enjoyed it, and maybe I'll finish this up in a addendum screencast and throw that out there so that you can see what the rest of the process is like involving in live and putting together a web form, that kind of thing. So I think Yasmina will.
Yes, thank you very much, Chaz. We do have some time left for some Q&A, and I'm sure the audience would really appreciate that. They have sent in some really great questions. Let me know if you're able to see them.
Oh, right. Let's see if I can get the right. So I'm going to kill the screen sharing here. And actually, I probably shouldn't have done that.
We're fine. I'll read them in the order they came in. We have a question here from Ravisara. They ask, what was your main motivational factor for learning Clojure? On a practical level, have you found Clojure to be more suitable for certain programming projects than others?
Right, I got back to that Q&A panel, so I think I'm good from here on out. Thanks, Yasmina. So my main factor for learning Clojure, so I started investigating it, let's see, very early 2008, I think like January or so. And it was very raw back then, but it clearly had a lot of characteristics that were appealing to me. I've been doing Java since 99 maybe, and built a business using Java, but starting around probably 2005 or so, really got tired of the lack of progress in the language, a certain degree of certain lack of forward motion in terms of the libraries and ecosystem, that kind of thing. And so I started looking around for better alternatives. I started doing all my web development in Python and started looking at other JVM languages because I didn't have an existing Java code base that I needed to interoperate with. So I started off with Scala, used that probably in the very late 2006, 2007 area, and that was a good step up from where I was, but it ended up not working out for me for a variety of very complicated reasons. Ended up putting it into production. Certainly had no qualms with it there, but it didn't feel like the right thing for what I was doing. I was working with a lot of fairly complicated problems that I wanted to have a lot more power behind instead of in Scala. I ended up struggling with tools a lot, which, back in 2007, I suppose that's to be expected. Clojure really impressed me with its focus on functional programming, with its focus on interactive development, because interactive development is really important for me in terms of very concretely seeing what's going on within the computer, understanding what's happening with the data that I'm manipulating or working with in general, and then being able to react to that immediately. As opposed to in Java and in Scala, I had developed all sorts of workarounds for dumping data out and massaging it around to bring that in for mocks and things like that. It was sort of a mess in that way compared to Clojure, which allows you to have a much more fluid working style. And in terms of whether it's suitable for certain programming projects more than others, people are doing a lot of everything with it. Everything from standard web stuff. Clojure has a great web stack. So doing anything that you would do using, Wicked or Play or Rack or Sinatra or Django or Rails, although Clojure doesn't have nearly as many of the frameworky kind of things that you might find in, say, Django or Rails. It's very much more focused on narrowly defined libraries, which is nice because you can swap them around. So, for example, instead of Composure for routing, I could use Mustache or Noir or any of the other Clojure web libraries that have a routing component to them. So you can swap these things in and out, and it applies to every layer of the stack, which is great because you don't get locked into a particular framework. So it's got a great web stack. It's used for scientific work. It's used for mathematics and analytics. It's used a lot with Hadoop and Cascalog and things like that. Excuse me. I guess I would, if you have projects that really demand deep interaction with particular tools or frameworks, then that might get a little hairy. I mean, Clojure has support for annotations and things like that, but certain environments, that have a pre-compilation step and things, obviously they're not going to consume Clojure source. So Clojure works well with Java libraries, as APIs essentially. But if you're doing like source-to-source transformations, that's clearly not going to work. There's art projects that use Clojure. So I mean, obviously I travel in the circles that I travel in that use Clojure well. I haven't heard of any Clojure horror stories necessarily. So I don't know of anywhere Clojure falls down badly. I think one thing is that you need to make sure that the people who are using Clojure are engaged. One thing that we say in the book a couple of times is that Clojure forces you to raise your game, but it pays you back for doing so. So if you are, if you're using Java right now, and if you're using Java right now and you don't want to do a whole lot of thinking, you want to stay within your existing pattern of work. So I suppose I shouldn't call it no thinking, but you don't want to think about your language or your tools that much. You don't want to learn about a new model for concurrency necessarily. You don't want to learn about immutability and functional programming. Then Clojure probably isn't going to be the greatest thing for you just because you won't be able to leverage all the things that it provides. So if you're an engaged developer, then you're going to be able to make a lot of hay with Clojure, I think. Okay, so moving through these a little faster perhaps. Shouldn't DoSync be around swap 2? Melopone Moody asks. No, because swap operates on atoms, and atoms do not participate in Clojure software transactional memory. So you only need to use DoSync to delimit the scope of a transaction when operating on refs, because refs are the only reference type that participate within transactions. Agents do as well to a certain degree, but it's a little subtle, and I'm not going to get into it here. But no, you wouldn't use DoSync around swap. So Juan Manuel Jimeno, perhaps, asks, why are you using a ref and an atom? Could you have just used 2 atoms? Yes, I could have used 2 atoms, I believe. Let's see. No, so if you, so the reason why I used a ref is that if you'll notice, remember, so see these multiple references of Apple. Later on, I was planning on putting in a check there to see if the URL was already present, and we would have had to change the map structure a little bit. So for that reason, I would have needed a ref. Just the way it is right now, another atom would have worked fine. You're correct. The actual example within the book, and if you go to github.com/closurebook, has all of the code from the book. It uses a ref and does some checks on the data structure within the ref prior to using alter, and so in that case you do still need the ref in order to ensure the consistency of the or the atomicity of the check versus the change. So John McKenzie asks, in the NS macro, what is the difference between use and require? And it also appears to take import and load in the attribute map. All these verbs sound almost the same to me. And yes, you're right. The NS form, the NS macro is does have a lot of options to it, and unfortunately so. There's been some effort to simplify that significantly. So starting in Clojure 1.4, there is some modification or some addition to the require portion of the configuration provided to the NS form that subsumes use for nearly all usages. So that helps. So the only thing I can suggest is read the documentation and absorb what NS does and what all the components do underneath. And so one good thing to note is that everything within NS is founded on other functions as well. So there's a use form and there's a use function. Let me make this a little larger here. Excuse me. So the arguments to the use function correspond to the arguments, quote unquote, within the use section configuring NS. So it's actually not particularly complicated in each piece. When it's all piled together within the NS macro, and if you don't know that, use is there, require is its own function, and then refer is used beneath it. So each of these things are broken down into primitives, so to speak, and NS is essentially a convenience macro. So you want to understand each of these separate components from the point of view of the functions that implement them, and then it will make a lot more sense. I should note that compared to, for example, all the different options that you can have within Java imports, for example, there aren't more working parts within NS and all the different functions that support namespaces in Clojure. It's just new. So it's a matter of reading a good book, reading some documentation, and sort of getting used to a new normal. So Fred Dode asks, can you please summarize best practices in deciding between use something? So again, there's a couple of questions about namespaces. So best practices, there are some best practices in Clojure programming. I'm not going to, if we spend a full chapter essentially on project organization and project management and how best to organize namespaces and things like that, and whether you should use refer or require or use or whatever. So I would refer to that. I'm not going to I couldn't repeat that here. In general, I was going to give a top level. Generally avoid use. I use it here, but I restrict what vars are referred into my current namespace to those that are listed. I enumerate them. If you were to do a bare use like this, that means that I bring in everything from Composer Core, which is generally not advisable, just because if in a later version Composer Core adds a new var or a new function, then you suddenly have that in your namespace as well without foreknowledge. And so you'll get some odd errors that you wouldn't be expecting otherwise, and there are some other caveats. So in general, if you're going to use, definitely qualify it with an enumerated set of vars you want to bring into the namespace. And in general, use require all the time with its various options, including as, which provides an alias, and there's a refer option in Clojure 1.4. Ben asks, I don't understand require So again, a question about the require form. This is requiring the handler and the Clojure handler and Clojure route namespaces. This is requiring ring util response and assigning it the alias within the current namespace of response. So any var within ring util response I can refer to with a response / foo. This is actually, I use that here. So I hope that answered that question. Justin Campbell, how do I load a file into the REPL in bash? So if you, by bash, I presume you mean if you started your REPL, say, using Leiningen from bash, then there is a load file function that you can pass a file path to. And Leiningen uses NREPL, the same REPL library that counterclockwise uses here. So you can connect to REPLs started from counterclockwise from Leiningen or vice versa. So that may help in your interactive development. The difference between parentheses and brackets in the require directive, I think they're equivalent. This may be out of habit more than anything else, but I think this is equivalent. Yeah, it's equivalent. So that difference right there is perhaps more. These simply need for prefix specifications here, or if you're going to provide an alias here, it just needs to be any sequence. So here I provided a list because that's by convention what I do to denote a prefix set of namespaces, and then I use vectors for everything else. Excuse me. So Luciano Ramalho asks, how do you reload it? That's just loading code through the REPL. So I'm using Control-L, which the default and counterclockwise is Option-Command-L. And all that's doing is it's sending the entire contents of this file over the pipe and loading it into the Clojure runtime. If you mean what happens when Clojure gets a hold of that code, it compiles it down to a set of Java classes at runtime, and each function, for example, implements an interface, and every function call within Clojure corresponds to a method call in Java. So everything is super fast. There's no interpreted mode. Clojure code is never interpreted. There's only a compiler that generates byte code at runtime, and yeah, hopefully that answers your question. Bertrand Duchot asks, what is the roadmap for Eclipse Leiningen support? Will it be in the Eclipse market? Laurent Petit is the lead for both counterclockwise and the Leiningen support in Eclipse, and that is largely up to him. I've been using the Leiningen support in Eclipse for, I'm going to say, a month now, so it's pretty new, but I'm using it for everything all of my Clojure development. So it's been rock solid so far, and I've been using counterclockwise for probably coming up on like a year. So that's been good. In terms of roadmap, there's a lot of ways I can answer that I'm not going to get into right this second. Why not publish Leiningen support to the Eclipse market again? That's something that Laurent is going to have to speak to, because I don't know anything about how that works. And I see that I think I saw that the immutable Michael Fogus is in the room, who asked, what was it like working with Christoph? Fogus being the co-author of Joy of Clojure. Nice to have you here, Michael. Working with Christoph was great. He provided an amazing set of content for the book that a lot of which I wouldn't have produced, so it was fantastic having him on board. Oh, I guess I'm showing the web console here. He was great to work with. I'm absolutely astonished that being a native French speaker, he managed to put together good English content. I know that he does so for his blog, but as anyone who has written a book knows, there's a great chasm between writing for a blog and writing for a book, and Christophe was able to produce book quality material in a very technical realm and in domains that I wouldn't have been able to touch. We all of our writing got edited down, but I was really impressed, and I think that just shows his level of comfort with the material and confidence in writing. So it was great working with Christophe. So I think the Q&A has dried up on my end. So I think they're going to kick us out of the conference room or something.